the other type of identities we have that we're going to talk about are double angle identities and half angle identities. I'm going to actually derive for you the double angle identities from our sum identities. Double angle just means there's two of them. So ultimately we're adding theta plus theta together. So if I had the sine of theta plus theta and I were to use my sum identity, that means that we would have the sine of theta cosine of theta plus the sine of theta cosine of theta. We would get, they're the same thing, so two of them. So the sine of essentially 2 theta equals 2 times the sine of theta cosine of theta. So that's the double angle identity for cosine. No, sorry, for sine, sorry. Now for cosine, we use the sum identity for cosine. We're going to get cosine of theta, sine of theta. Nope, wrong identity. They're hard to remember myself too. So cosine of theta, cosine of beta, which happens to be theta, minus the sine of theta, sine of theta, which ends up being cosine squared of theta minus the sine squared of theta. And with that one, we can actually kind of combine. We can keep it as that, or we can do two other things, and we can write it two ways. So these are what you want to write down. The sine of 2 theta equals 2 sine cosine. And the sine of 2 theta, so this is it oh, why does it do that? This is it stop. Unsimplified at all, and then, so that's when we came up with the formula. And then if you actually use some identities, you could get the other two. So those are 4 identities that you want to write down as well. You can hit pause. And then we also have half angles. I'm not going to derive those for you. Basically, that means we're trying to find the sine of an angle over 2 or the cosine of angle over 2. They involve square roots, and you are going to want these as well.